So z-scores. So this is a z-score practice worksheet. I've got my model drawn here, and I've got multiple models that we're going to go through and answer these questions, and I hope it helps. So looking at this, we say, all right, a normal distribution has a standard deviation of 10. So this distance is plus 10. This would be plus 20. This would be plus 30. It doesn't matter what the mean is. This is just the numbers we have. This would be minus 10. This would be minus 20. And this would be minus 30 from the mean. Whatever the mean is, it doesn't matter on this. So it says find the z-scores corresponding to each of the following values. So we look at a score that is 20 points above the mean. Well, a z-score is my raw score minus my mean divided by the standard deviation. Well, it tells me my standard deviation is 10. That's an S, not a 5, for those who can't read my writing. That's an S. Okay, so it says it's 20 points above. So this number right here, well, from here to here is 20. So I do 20 divided by 10. The difference of the mean and the raw score divided by 10 is 2. So that's a z-score of 2. Yeah, it's that easy. So when I have 10 points below the mean, so again, my difference this time is a negative 10 divided by 10. So that z-score is a negative 1. I dare say you can answer this next one. 30 points below, way down here. So that means this score would be a negative 3. Oh, I missed one. The 15 points above the mean, 15 points above the mean, would be right here. But still my difference is 15 divided by 10. So that's a z-score of 1.5. So my z-scores are 2, negative 1, 1.5, and a negative 3. Well, let's look at this next one. So we're doing the Wechsler scale for intelligence. I failed that, by the way. Most of you would probably agree with that. So it's composed of a number of subsets. One of the subsets, the raw score mean of 35. So this is 35. Standard deviation of 6. So I'm going to throw some numbers in here real quick. Okay, so it says a raw score, of 35 with a standard deviation of 6. So that's 41. This would be 47. 6 from this makes that 29. Makes this number 23. We're just going to start right there for right now. Now, what number represents the 65th percentile, or what number separates the lowest 65% of the distribution? So to determine that, we look at our picture and say, okay, so the 65th percentile, this is the 50th percentile right here. So I go, just as a mark, 10 points above. Okay, so now this is the 60th percentile, or 60% of the graph falls to the left. So this is where we go to our handy dandy calculator. All right, let me turn that light off. Does that make a difference? Yeah, that makes it worse. We'll turn the light back on and see if we can arrange this somewhere. So we're looking at 60% below this number, 60% below that number. So thinking of that, what we'll do is use our calculator here. And to use the calculator, we're going to go second distribution. Okay, we've talked about this. The second button, and distribution, which is the blue word DISTR right here above vars, which stands for variables, next to clear. So we're going to use what is called the inverse norm, inverse normal. So to use this, and I'm going to write inverse norm here, we're going to look at the area. Well, the area to the left of this point is 60%, so that's 0.60. So put in my 0.6. Now my mean is 35. and my standard deviation is 6. So we have 0.6. I put the 0 there. It's all right that we have it. 35 and 6. Okay. So we have our inverse norm, 0.6, 60%, mean standard deviation, and that number is 36.5. And we're okay to use that number. So that's going to be 36.5. That's our raw score. Then it says what number represents the 90th percentile. So somewhere out here is the 90th percentile, right about there. So second distribution, number 3, and instead of 0.6, we're going to use 0.9. So again, it's inverse norm, 0.9, 35, our mean standard deviation of 6, and that's going to equal, paste, 42.7 is what we're going to say. We're going to say about up here as well, 42.7. Using the inverse norm, we find the area under the curve, the percent, the mean, the standard deviation. Okay, now the next question is a little bit different. It says, what is the probability of getting a raw score between 28 and 38? Right here is approximately 28. Right here is 38. Okay, so between here and here. So we're wanting that area. I don't use inverse norm this time. We want the cumulative area there. We want the total area between 38 and 28. So in other words, we want this area right here. We want all that area there underneath the curve. So to find that, I don't use inverse norm. We use the normal CDF. So my lower number here to the left, what's the farthest left number I'm dealing with? It's 28. My upper number is going to be 38. Again, I put in my mean, my standard deviation of 6. So now we need to write, let me get this on here. Excuse me. Now we have a normal CDF where we have 28 is the lower number. We will later label, make sure we label these correctly. Put an L above that. 28 is the lower. Oh, Tacos for Life just texted me. 38 is my upper. My mean is 35. My standard deviation is 6. Isn't it 6? Yeah. And that's going to be approximately, we're looking at a probability. I'm just going to call that 57%. Is that okay with y'all? Look at all those numbers. We're rounding up hardcore there. So I'm going to write as approximately 57%. Same thing on the next one. Next question says probability of between 41, which is up here, and 44, which is probably, let's see, somewhere right around here. This was what, a while ago? What number was that? Oh, we were just talking about the 90th percentile. Yeah. So, excuse me. So again, it's going to be a normal CDF. This time I'm going to label things a little bit better. You want to see this though, don't you? Normal CDF. A normal CDF, and I'm going to write I'm going to write lower to what I get for picking up a pen. It can be 41. My upper can be 44. My X bar is 35. And my S is 6. That's an S, folks, not a 5. Okay, so here we go. I'm just going to do something fun right here. Now I'll go ahead and continue to do what I've been doing. Second distribution, we're doing a normal cumulative density function. So I have 41, 44, 35, and 6. And that's about 9%, 0.918. Even if that becomes a 2, I'm going to say about 9%. Oh, this is a lot of fun, a lot of fun. Okay, so here we go, using these same concepts. So now we're looking at the SAT. We use 500, standard deviation's 100. Okay, this should be, that's interesting. What is the minimum score necessary to be on the top 15%? The top 15%. So with this one, we're looking at our graph here, the top 15%. So our numbers are 500, 600, 700. I'm not even going to go below because we're talking about the top 15%. So this is 2.5% right here. And this, 13.5 and 2.5 makes 16%. So we want the top 15%. So it's somewhere right in here. Okay, the top 15%. So we're looking at this direction. Well, this direction is 15%. That direction below that would be, correct, 85%. So here we go, 85%. We're doing, again, area under the curve is given to us. So we're doing inverse norm, 0.85, 500, 100. That tells us a score of about 603. Okay, that's about a 603. So let's write down our thing here. Inverse norm. So that's going to be 0.85, 500, 100, and then our number. Whoops, sorry, I put that too close. That's 603. So this is area. Why are you quitting writing on me here, pen? Area, there we go. X bar and S. Oh, it called it mu up there, so we better call it mu down here because it is a population. Okay, so that's the area under the curve. So a score of about 603. Then the next question says, whoops, find the range z-score values that define the middle 80% of the distribution. Okay, well look, here's 372. So we know that z-scores to find a z-score, I've already written this down, it's the raw score minus the mu over the sigma. Then they give it to us. So we're going to find each of these. So I'm going to say 372 minus 500 divided by 100. That's my lower z-score. And then we're going to go 628, raw score minus mean divided by 100. So here we go, 375 minus, 500, close parentheses, divided by 100. It's a negative 1.25. Is that z-score? And I bet this is the same because it gives us this, because it's 80%. That means it's 30% of each side of the graph. So I'm going to go ahead and write, watch how confident I am. I'm going to go ahead and write this number is a positive 1.25, but we'll go ahead and calculate it. This was a negative 1.25, so I bet this is a positive. Hint, hint, folks, you will see things like this again. Now I'm going to do something creative. I'm going to press second enter, and that pops that back up on the calculator. So I can just overwrite this, 628, enter. Oh, what did I do wrong? Oh, I put 372. Why didn't y'all tell me I did that wrong? Second enter, second enter. Oh, toots. Yeah, negative 1.28. Watch that 5 become an 8 right there. Some of y'all were saying, Pruitt, when I did that, I didn't get that number. See, I guessed I got it wrong. Okay. So now, for a normal distribution, we're going to find a z-score that separates the distribution as follows. So we're going to separate 30% from the rest of the distribution. The z-score that does that, the highest 30, the lowest 40, and the highest 75. So this is going to be 0.7. This one's going to be 0.4. And this one's going to be 0.25. And 0 and 1, because those are going to be my means and my standard deviations, because it's the z-score. It's just the simple z-score. So here we go. Second distribution, 2. Oh, I'm sorry, not second distribution 2. We're looking for z-score. Second distribution, 3. Oh, second distribution, 3. So this is going to be 0.7, because the highest 30% means we're trying to find the point of the lowest 70%. So 0.7001, that z-score is 0.5. Okay, second enter, still inverse norm. Change the 7 to a 4. It's a negative 2.5. 0.25, sorry. Thank you for that correction. Negative 0.25. And then the highest 75% is the 0.25. Means we're going to start low. 0.2501. Whoops. Delete. It's a negative 0.67. Okay. Sorry, that was 0.52, because we're going to show that to the hundredths place each time. So the z-score for 30, the highest 30% is a 0.52. That means 70% of the distributions are below the 52nd percentile. 40%, a z-score of 0.52, not 52nd percentile. These are my percentiles. And 40%, the lowest 40, is a negative 0.25, and the highest 75. That means I'm looking at a graph, and right here is 75% and greater. So we find the area of this, which is 0.25, 0, and 1, and that's a z-score of negative 0.67. Okay, so that's the first half of our video, first of 3. I'm going to continue the other pages here momentarily, but I'm going to go ahead and post this one for people to use. If you have any questions, shoot me another email. Thanks.